Witam wszystkich Państwa. To kolejny odcinek kanału klimatycznego. Tak jak zapowiadałam, dzisiaj będziemy rozmawiać z panem profesorem Andersem Levermannem z Instytutu zajmującego się zmianą klimatu i wpływem zmiany klimatu na nasz świat w Poczdamie. I będzie to rozmowa dotyczyła tego najświeższego badania z Nature, które mówi o tym, że do 2049 roku straty budżetów całej, powiedzmy, global income będzie wynosić 19%. No to teraz przestawiamy się na język angielski, bo tak jak Państwo się pewnie domyślacie, nasz gość jest angielskojęzyczny. So I would like to welcome once again Professor Anders Levermann from Potsdam Institute for Climate Impact Research. Hello, and thank you that you are with us.
Yeah, hello. Thank you very much for having me.
Yes, so basically we talk today about the latest groundbreaking research you published with your colleagues, together with your colleagues on April 17th in Nature Scientific Journal, which says more or less that no matter what we do as it comes to emissions, we will lose, the world will lose global income by 90% till 2049. How it's possible actually that no matter how much greenhouse gases will put to the atmosphere, the outcome is the same?
This is already known for a very long time. It's not an economic effect, it's a climate effect. The climate change that we are currently seeing has been caused by the emissions of the past 20 years. So in the next 20 years, we will cause the warming of the time after the next 20 years, because there's a time delay in the response of the climate system to our action, to our carbon emissions. That is mainly because the ocean is taking up most of the heat that we are storing on the planet, right? There's just because we're starting here and we want to talk about economics, that's great. But I'm a theoretical physicist by training, and I just have to, in the beginning, say that we understand the physics of climate change very, very deeply, and it's not a climate scientist thing. It's really a quantum mechanics thing, because we know the molecules CO2 and CH4, methane and CO2 and carbon dioxide, and also the others, nitrous oxides and so on. We know how they respond when they interact with light. You cannot see CO2. If you look outside, you can't see it. It's a molecule, but you can't see it. And that just means, that's just in physics terms, that just means it lets visible light that's coming from the sun through, right? And the sun is mainly giving us visible light and a little bit of UV, ultraviolet. But the stuff that's coming back from the Earth is mainly infrared. It's mainly heat. So obviously the Earth is visible from space, so we are also emitting visible light, but mainly infrared. And this is where the molecule CO2, CH4, they take up the energy that wants to get out into space, and they take it up, and we emit it, half of it down, half of it up, and that warms the planet, very simply. And then there's the next stage, that's the greenhouse effect, and then there's the next stage, and that's actually also physics that everyone knows. I'm going to talk a little bit about, and that is a warmer atmosphere can hold more water vapor. Everyone experiences this. People who have glasses, for example, if they go in winter, if they come from the outside and go to the inside, into the warm house, the glasses, they can't see anymore because the glasses get water. And that's because the warmer atmosphere inside has more water vapor, and the glasses are still cold, and it condensates on the glass. So this means that the warming that we get from the greenhouse effect leads to more water vapor in the atmosphere, and that is again a greenhouse gas. H2O, right? Water is a greenhouse gas, and that gives you additional warming and that's why we get the warming. You ask a short question, I answered very longly. I won't do this again, but I have to say it once. So you can see in all the warming scenarios, the next 20 years are already fixed, which doesn't mean that we don't have to do anything with respect to climate mitigation, because the 20 years afterwards, we are
It's
determining
even
now.
worse. Yes, it's even
going to be
worse.
worse if we don't do anything. Yeah.
Yeah, exactly. So just to show our viewers the research about we are talking about now, it's here in Nature, and in a moment I will show you the link where you can get it, so everybody knows what we are talking about actually. So it's but it's certainly 19%, because I also read in the research that those are quite conservative estimations. So it might mean that it can be also even more, right?
Yes, I mean what we did was well, there have been estimates of how much climate change will cost. People, when people talk about climate and money, they generally talk about how much protecting the climate, limiting the warming, how much that costs, right? There's a lot of, I don't know how it is in Poland. In Germany, everyone talks about that all the time, right? And so these estimations have been around for a while. How much would it cost to stay below 1.5 degrees, which is not possible anymore because we already passed it last year. Well, anyway, but there's still, we just passed it once, so perhaps we go down next year, and then we still have a chance. But in order to stay below 2 degrees, we know how much it'll cost if we do it right. It's not. It's, by the way, it's just a structural change, right? It's going from oil, gas, and coal to wind and solar. That's basically what it is. There's nothing. There's also the problem with concrete, but basically that's basically what it is. So we know how much that costs, but then there have been estimates of how much climate change will cost, right? And that's the damages that are caused. And the first really strong estimate was from Nicholas Stern in 2007, who wrote the so-called Stern Report and got a lot of heat for that. He was criticized a lot. He was the former chief economist of the World Bank, and is still with the London School of Economics, a very renowned institution. And he estimated the cost of climate change to be much higher than previously thought. So he got criticized a lot. And then there has been a study from Stanford University in 2015 where the costs were already estimated to be higher. And the reason why this was higher was that our colleagues in Stanford found that climate change is not just affecting the economy in 1 year, but it can change economic growth. And economic growth, if you affect economic growth, then the damage, the money that you're losing in 1 year is transferred to the next year, because you don't have this money available for investment and for further growth.
A bit like a snowball, yeah?
Exactly. So yeah, exactly. It's carried over the years. So the big question was, how long does a perturbation from climate, how long does it last in the climate system, in the economic system? So the Stanford guys, they assumed it'll stay there forever. That was a bit of a wild assumption, and they were criticized for that. There was also a Nature paper, by the way, a really a very good one, because it opened up this idea. In our study, we investigated specifically how long does the damage last when the temperature is too high or other factors occur. And we were able to, we had enough data to estimate how long it stays. And we found that, for example, a temperature signal will stay up to 10 years in the economic system, while a rainfall event, a rainfall change, will stay about 4 to 5 years only. So we were able to kind of constrain our estimates for the future with these new data. But, and that's something in addition, so this would make the damages smaller compared to the Stanford analysis. But we found in an earlier Nature paper in 2022, which was actually the cover of Nature back then, we found that rainfall also affects climate, not just the temperature. And rainfall will also change under global warming. So we added this together with the constraint of how long it'll last in the economic system. And we found that then the damages are actually even higher than the ones estimated by Stanford University and much higher than what Nicholas Stern estimated in 2006, where everyone thought this is an overestimation. It's not.
Before I ask another question, I would like to encourage our viewers to ask questions. This is your only chance, and I promise you that all questions will be showed to Professor Levermann. And now I would like to show the main graph from the research, where we have, as I understand, three different things. First of all, it's like a green line, which says about costs of mitigation. Then we have a purple, which says that more or less we are net zero by 2050, yes, and those are costs related to this scenario. And the third one, the orange, as I understand, is the worst case scenario, meaning that we emit more than we should to stay before 2 degrees Celsius of warming compared to pre-industrial period. Huh?
Yes, you can actually say that the RCP 2.6, that's what it's called, the blue one or purple one, is keeping you below 2 degrees of global warming, exactly as you said. So it's barely keeping the Paris Climate Agreement, and that's a very important physical fact again, that we can only stabilize the temperature of the planet if we stop burning oil, gas, and coal altogether. That is very often a shocker because people, I give talks to industry a lot, and people generally think, oh dear, this is like I'm an extreme climate scientist. But this is not a political statement at all. It's very simple. The carbon, the sea, right, that we take out of the atmosphere, out of the ground in form of oil, gas, and coal, has been out of the atmosphere for 100 million years. We are oxidizing it, so we burn it to become CO2, and this is an extra CO2. So it's not, there's no sink for it. Nothing is taking it out of the atmosphere again. If we exhale CO2, that's what we do every time we exhale CO2. This is CO2 where the C is something that we just ate. We just ate either a vegetarian meal or meat or whatever you ate. This provided you with a C, and then you inhale O2 and you exhale CO2. But this CO2 has been taken out of the atmosphere a short while ago, when whatever you're eating has been grown, right? It's always.
So this is like within the carbon cycle, right?
Exactly. I call this the shallow carbon cycle, because the CO2 that we are exhaling, the C has been taken out of the atmosphere a few months ago or a few years ago. But the CO2 that's coming out of a furnace from a factory, from a power plant, has been taken out of the ground. So it has been out of the atmosphere for 100 million years. And we add it up. And I can show you a graph. Well, we have a publication from Science Advances a long time ago, but 2014, I think. It's on my webpage. Everything is always open, so everyone can have everything. But where you can see that CO2, once it emitted into the atmosphere, stays there for hundreds of years. In my book, I showed it until 4,000 after Christ, but you can prolong it until 12,000. In the paper, it's until the year 12,000 after Christ, and it's still, most of the CO2 is still in there. So that means that we have to go to zero emissions, and that's why the blue curve is actually stabilizing, because there we get to zero emissions. And zero emissions are good for the economy, actually, because it means that you don't have to do less, you have to do something different, right? Because you have to just change from oil, gas, and coal. And I know that's a big deal for Poland. It's big deal for Germany too. It's a big deal for everyone. But the European Union and the United States both have said they want to be at zero in 2045. So, and only then you can stabilize the temperature of the planet. And the red curve, or what you call the orange curve here, well, it's orange. You're completely right. We call it red because it's what we put in the program to be. We said, let it be red, and then orange came out. But anyway, so it's this one gives you 5 degrees of global warming by the end of the century, right? That's basically what it is. And the point is, and that's important, if we don't stop emitting carbon by the end of the century and follow the red curve, it's continuous, because we have found, then 100 years later it'll be 10 degrees, and 100 years later it'll be 15 degrees, and then we don't have anything anymore. We found enough oil, gas, and coal, and it's mainly coal, really. Oil and gas relatively small. Coal to warm the planet by 15 degrees, right? And we can talk about this, how bad that would be, in a minute, but we don't have to. We can, but that's, you want to talk about economic science.
Yeah, so just to put it clearly, no matter what we do until 2050, we still have income cut by at least 90%, but still this cost is sixfold less than just a process of decarbonization or energy transition, what is a green line here, right?
Exactly. You can see it very well in this figure, in this graph. The dashed line is basically 2050, right? And you can see that the two lines, the red and the blue, are basically the same, close until 2000, what is it, 30 or so, 35. And then they start to deviate a little bit, but the uncertainty range around them is still big. So we consider them to be indistinguishable scientifically from each other. They're still the same until 2050. And that's why we call this the commitment. That's basically the cost that we have already caused. And compared to this are the mitigation costs. So the cost to stay below 2 degrees, this are the green curve, is 6 times smaller. You can see it's much smaller already in the graph. And what I want to highlight, and that's important, the economy is growing in different rates, right? And what you see here is the difference to whatever the economy would be without climate change. So it's most likely, if the economy is growing strong, it's most likely going to be still a higher, stronger economy. It's just reduced by 20% compared to what it would be without climate change. That's important to note, because we're not going down, we're still going up.
Yeah,
at least in those countries.
Yeah, but we could have been richer, let's say. That's
much richer, and 20% is a big deal. It doesn't sound a lot to a physicist. It doesn't sound a lot to perhaps to some people. It's a lot for economists. I can tell you that. The world economic crisis is world economic crisis generally associated with a 20% reduction in GDP.
And another graph, because we see differences between different regions as it comes to losses you predicted. In general, in the research, the research determines that in Europe and North America, it will be about 11%. And why we see those differences between regions, especially, for instance, in Central Asia and Russia, where we see that those losses are more or less the same in the both scenarios. This is the first question, and the second question is and the second question will be posed afterwards.
Yeah. It's big because I'm answering so long, so you're storing already. Yes.
Yeah.
I'm trying to be better. What you see here is the different regions, and the reason for the difference is because the climate change will be different in different regions. Very hot regions that are already hot today will suffer the most, and that is very unjust, because it's the global south that is has caused the least of the climate change that we've seen already now, and that we will see in the next 20 years. The countries that contributed most to this have been Europe and the United States, and now China, right? Countries which are very far north um, might even benefit from this slightly, because they're getting into a more favorable temperature zone. At the moment, this is basically Russia and Canada. These are the two countries. If you want, you can show the map there where one can see it, but you can see it already here that Central Asia and Russia don't see any net negative. That's because Russia is actually slightly benefiting, not a lot, but slightly benefiting, and some Central Asian countries will lose a little. But if you average over them, then that's the case, and that is mainly because of the temperature change, but also because of precipitation changes. But you see mainly the temperature change here.
Did you bear in mind also the fact that Europe is the fastest warming region in the world?
This is already included here, because what we did was we used perhaps we can talk a little bit about the methodology.
But afterwards, yeah.
Afterwards, all right.
Yeah.
Yeah, it's accounted for. Yeah, it's accounted for. It's in here.
And but like bearing in mind also what we see in here on those graphs, did you take into account also the adaptation possibilities? Because as we know, like richer country is, it has more possibilities to adapt to climate change. So in case of global south, the adaptation is let's say less possible. So
yes, and I think this is why we have to already get into the methodology now, because so that people understand where these estimates come from, right? We are not wizards. We don't know the economy of the next 25 years, right? If we could be, you could be very, very rich if you know how the economy evolves in the next 20 years. Also, what's not included here, what people might think is important, is destruction from extreme events. For example, a flood that destroys a city or a factory, or a heat wave that, or a hurricane or a typhoon or any storm that is destroying something. Now, this destruction is generally, it sounds awful, but it's generally good for the economy, at least in countries where there is enough money to rebuild whatever has been destroyed, right? In countries where you don't rebuild it, where it just stays destroyed, then it doesn't. But if, for example, in European countries or in the United States, people will be either insured or they will rebuild themselves, and that means economic activity for the rebuilding. So the destruction actually amplifies the economic motion. And so this is not what you see here. It's not the destruction from climate events, but, and that is important because it's a very strong difference, it's the perturbation of the economy by unforeseen events. If the temperature is higher than you thought it would be, if one day is higher, the next is warmer, the next is colder again, and then it's higher again. This up and down, the variability is a problem. When you have more rainy days that you didn't expect, if a summer is more rainy than it is expected to be, or it's drier than expected, these are the perturbations that then affect the economic growth. And this relates to the possibility of adaptation, because it's basically a hidden thing. And you don't realize that you are being slowed down necessarily, because it's not a big event. It's just something that that we observed. And now I need to tell you how we got to this data. What we did was we looked at the economic data of the past 40 years. on a very high spatial resolution. So not just on a country level, but on a subnational level. So I don't know, actually, shame on me, but I don't know how it's called, how the subnational level is called in Poland. Like in Germany, it would be Bundesländer. In the United States, it would be the states. In China, it would be provinces, right? So on this level, we looked at the economic
like
data.
regional, something like that.
Exactly.
This what you mean? Yeah. Okay.
Yeah. So sub-regions that are like small enough so that climate actually can, weather changes there. So we looked at this, and then we looked at the climate data, and we looked at the annual mean temperature, so the average over the year. We looked at the variability from day to day in temperature. We looked at the rainfall that falls in a whole year in a region. That's actually good for the economy everywhere on the planet. If there's more, that's a good thing. So, but, and that's surprising, if you have more rainy days, it sounds like a contradiction. If you have more rainy days, that's bad for the economy almost everywhere, because more rain is good, but if there are more rainy days, that's bad, and that means there was rain on a day where you didn't expect it, and then your transportation doesn't work, or something like this. And then we also looked at extreme rainfall events, and we also looked at deviations from the seasonal cycle. So if a summer is wet or dry compared to what you expect it to be. So we put all this and looked, how does economic growth is affected by these variables. How was it affected in the past 40 years? So this is a huge data set, actually. And from this, we derived relations. So we can say, for example, that if a region gets 10 more rainy days in a year than it had before, then the GDP, so the economic growth, goes down by 1%. Not the GDP goes down by 1%, but the GDP growth, the gross domestic product growth, goes down by 1%, which means if you had 3% economic growth, you only have 2%, right? And this is something that we analyzed for the temperature variability, for the annual mean temperature, for the rainfall. That was the last Nature paper, the one 2 years ago. And now we put all this together and added the climate models. We used all the climate models that were available, 21 climate models.
From I mean, those coming from IPCC, as I understand.
Yes, they're not. Yes, you're completely right. It's not like perfectly phrased, because IPCC is not doing them. It's countries, it's research institutions everywhere around the planet, right? We have Russians, we have Chinese, we have American. There's only one from Germany, actually. The UK has climate models, and yeah, a lot of countries have a climate model, and they put a lot of effort into this, right? It's a huge undertaking. Ours is in Hamburg, and like I think 15 people are working on this model all the time. They try to get it better and better, and it gets better every year. And then they are collected in the IPCC. So we use these, and then we also corrected for the weather, because these climate models are not meant to make weather predictions, right? But they can model changes in the weather, and you can use some statistics to correct so that it actually fits to the present day, and then you can kind of trust the next 20 years, 25 years or so. And that's what we did, and then we combined with the economic data and made these predictions that you saw. And why I'm saying that and how it relates to the adaptation is, the adaptation that we have done in the past 40 years is included. You see, no one would, I think, at least that in my experience, when I talk to industry, no one's really paying attention to climate change with respect to their production, right? No one is really, they don't worry about climate change when they think about their supply chains or their production sites or something like this. So there was very little adaptation in the past, but there's obviously some measures that try to protect the production against extreme rainfall, against supply chain failure, against heat, or something like this, right? There's already protection in place. And so the projections that you saw for the costs, they assume that this, what we've seen in the past 40 years, will stay the same in the next 20. That's basically what it is.
Yeah, you anticipated my question a little bit, but I would like to stress one thing, which you found in this research, meaning that the first and the most decisive factor of losses is the variability of temperatures, daily temperatures, the huge differences in daily temperatures, right? That this is the most important factor deciding
No,
about.
it's the annual
Mhm.
mean temperature, actually.
Annual.
Annual mean. Yeah, it's
Mm-hmm.
surprising, because I don't think the annual mean temperature itself is affecting the economy. I think it has to be an indicator for something, and people have analyzed this, and we will analyze this further. But we think that it's the heat waves that go up with the annual mean temperature. You can see that. You can see it actually in the background, in your background.
Mm-hmm. Yeah.
You have the
Yes.
red lines and the
Yeah.
blue lines.
Yeah.
So if you shift the distribution towards warmer temperatures, then the heat waves get much more intense, right?
So actually, the heat waves are the worst. Not floods, not winds, strong winds, no tornadoes, nothing like that.
Well,
But
we don't have these in the analysis. We only have the annual mean temperature, which we think is an indicator for the heat waves. We have the day-to-day temperature variability, which I think is a perturbation of everyday life. People get more sick when it's getting cold and warm and cold and warm. Things get perturbed by that. And then we have the rainfall, the annual mean rainfall, the rainy days, and so on and so forth. We don't have destruction by winds and so on.
so you didn't include actually those the most extreme weather events caused by climate change.
Exactly.
Why?
Because they are they're not
Unpredictable, right?
yeah, and very rare in the past. So you can't do good statistics with them. And also, and that's what I meant earlier, they generally are not necessarily a bad thing for the economy. It sounds so bad because people really suffer. People get their houses destroyed. People even die, obviously. So it's a terrible thing. But the economy is generally, in very many cases, profiting from this, and that's not because they're bad people. It's because they're rebuilding everything, and that's just generating activity.
Yeah, it drives economy. Yeah, that's
Yeah.
clear. Okay, we have a question from our viewer. So the study only looked at per capita numbers of the entire nations. Does the professor have data about the income decrease for the specific economic classes? I suspect poor classes will be fucked over like always more than the rich. But yeah, I think.
We don't have any. It's not just for the entire country, but it's for the regions. So we are on a subnational level, but there's no. This is really just the GDP. So it's just a gross domestic product, and how it is distributed within the country. I think your guess is quite right, but it's not part of our study.
Mm-hmm. And how did you collect this data actually? Because I also read at the beginning of this research that you included like 1,600 regions worldwide over the past 40 years, but this was said, yes. So how did you collect data from those regions, basically?
Yes, this is actually a very tedious work and very bright, very difficult work by my colleagues, Leonie Wenz, Dr. Leonie Wenz, who's a co-author of this study, who actually led the study, and But it was in an earlier study together with Professor Matthias Kalkuhl, and they collected this data, and it's a very unique data set that is openly, by the way, openly available, and everyone can use it, and a lot of people use it now, and so did we for the last 4 years.
Mm-hmm. So it
And we collect, and it's taken from the different regions. You see, the GDP of a country you can actually get online quite easily. For the sub-country level, sub-national level, you have to try to find it online sometimes, but sometimes it's not available. So you have to call the people or write an email and get the data, and it's a lot of work, right? That's also why we're lacking some data in Africa. Africa is actually quite a problem for
because
this.
they do not collect and do not publish it, right?
Exactly. So that's not included.
Okay, I
And
understand.
all of this, and also what you mentioned earlier, that we don't actually have and we don't look at tropical cyclones, so like typhoons and hurricanes and other storms, shows you that we are most likely underestimating the damages.
Yeah, exactly. Because, like even this week and last week, those floods in Dubai, which were completely unpredictable because never rains like that in Dubai. This week we have like terrible floods in south of China. So
But
all of it
floods
actually
are
brings
included.
loss.
So extreme
Okay.
rainfall events are included, right? It's just yeah, that's included.
Yeah. So it doesn't brings the raise of GDP
Say again.
afterwards. So it doesn't bring the rise of GDP afterwards.
The signal that we get from extreme rainfall events is actually very small, and the reason for that is because is most likely that there is some recovery effect that is good for the economy, but there remains a little bit of damage. Yes, so it's that's why it's small. It's very often associated with destruction, which is then being rebuilt.
And coming back to the methodology, I also read in the research that you used um, Monte Carlo procedure. What does it mean? What is it? Could you just like explain it simply?
Yes, Monte Carlo procedure is used a lot in very different places, and it means it is called Monte Carlo because it's a random choice. That's whenever you sample your data, so you pick your data randomly in order to avoid that the order of the data is important. So when Monte Carlo methods are in statistics are often used in order to make sure that it's not an artifact that you're seeing, that it's actually a correlation between two quantities that is real. So that actually temperature is really changing the economic growth, and it's not just by chance. And that's why you basically reorganize your data, you shuffle it around, and then we do your analysis and you check whether it's still true. And we did this, and it's a common statistical method. It's been Monte Carlo methods are used actually in a lot of things, not just in statistics. Yeah. And it's called Monte Carlo because it's a gambling game. It's not a gambling game, it's statistics. But yeah.
And going back to the results, like, don't you afraid that now actually some people will say, okay, so let's skip the transition. It doesn't make any sense because still, like it will cut 20%, almost 20% of our income.
Yes, if you want, you can show the figure again, the time series, because this is a good reason. You see, the 20% is up to the dashed line, the vertical dashed line, and you can see what happens if we don't do climate protection. It goes to 60%, and then it goes, if we continue, it'll go to 100, and then we have a problem. We have a problem much earlier, but on this path we have a problem. And as I said earlier, if we don't do any climate protection, we'll end up with 5 degrees of global warming. There is the so-called Clausius-Clapeyron equation that was found in 1834. It's very basic physics. And what it says is that for every degree of warming, you get 7% more water vapor in the atmosphere. And that means 7% stronger flood events, because the flood events, the extreme rainfall events, they are determined by how much water you can actually have in the atmosphere. Now, that means 7% for every degree of warming doesn't sound like a lot, but it means that flood events become 17% more likely for every degree of warming. Now, we have already seen 1.5 degrees globally. On land, that means 3 degrees. In Europe, it means 3 degrees. 3 degrees increased by 17% means we have already now seen 60% increase in the frequency of extreme rainfall events. That's why we see these floods all the time. If we continue, that'll become, at 2 degrees of global warming, we'll have doubled the number of extreme rainfall events. At 5 degrees, it's enormous. I haven't crushed down the numbers. I can do it actually now if you want, but it's going to be a lot. Real life science. I'll do it now. It will have increased by 500%. At 5 degrees of global warming, we'll have 500. We'll have 6 times the number of. We'll have 5 times the number of flood events that we have now.
And just like trying to, let's say, transfer it to the very simple way of thinking for ordinary people, this good scenario, which is like a blue or purple scenario, means which we actually will experience for sure. It's 19% of cut of our income. What does it mean for ordinary people? Just like, for like middle class in Europe, for instance.
So if your life gets better throughout your year because you're earning money and you're saving money, then this means that climate change is taking a fifth away from what you saved. That's basically what it is, right? You earn money and you put it on the bank, and you over your time you try to save more and become small. Climate change is taking 1/5 away, 20% away in the next 20 years.
And in the worst case scenario, which is like
it'll be 20 years old, it'll be also 20% in the next 20 years, but then it'll continue to become, as you see here, 60% and so on, right? Until nothing's left.
So we actually end up as bankrupts.
That's it. I mean, you see, the problem is that this is really slowing us down. And especially countries that are on a rising path, like Poland and other countries, they don't want to be slowed down. And climate change is not an idea by some wealthy left-winged people from Germany or Western Europe. It's basic physics that actually was developed a long time ago, and it tells you that and it's disturbing our way of life.
Yeah, and we have another question from our viewer, which actually is quite reasonable, because we know very well that the transition could go much faster. But the problem is that we have some laggards and we have some lobbies which actually act against the transition, and they try to stop it. And the question is, who should pay for climate inaction?
Yes, that's a good question, and that is being discussed in the climate conferences. Every year, all the countries come together, right, and have a conference on this. It's not a physics question. It's not an economic. It's an economic question, and obviously, but it's something that we need to decide together. I mean, how the climate change that we are experiencing now has been caused by the past 150 years of emissions. We know these emissions. We know how much it was contributed by whom, and it's probably a good starting point to say that this is the ratio by which the climate change costs should be paid, right? So I don't know the numbers of the top of my head, but if Western Europe or Europe has caused 40% of the greenhouse gas emission of the past, it's probably what it should pay for the damages.
Yeah, but we say Europe, or we say also just oil companies, for instance, the global oil companies, which earned the most on climate change, in fact.
Yes, I guess that's a good question. We can see already that it becomes more complicated the moment you start thinking about it. But yes, but it's a reality, and that has to be discussed. It's important, I think, that we realize that the money that's associated with climate is not the money we spend for renewable energies. It's the money that we spend on cleaning up the mess that we have caused.
Yeah, exactly, and this is the worst because it means that we waste those money, and if not climate change, it wouldn't be necessary. In fact,
Exactly.
and so you raised one interesting thing, which is, I think, very important to stress, because not everybody understands that. Because like, even recently I have had a discussion with somebody on Twitter, and this person told me, like, why actually Europe should cut now emissions so harshly, why our climate policy is so strict, so determined, if we emit only 7% of greenhouse gases. And I says, hey, hello, but we counted till 1850, because this carbon dioxide and greenhouse gases doesn't just vapor by the miracle from the atmosphere. So if you could just like put it clearly, why we actually counted like a like from 1850, and that means that the US and is the first emitter, and the second is Europe.
Yes, I mean, you were completely right the way you answered, but there's actually there is something that is actually changing the whole picture even stronger, and that is what I said earlier. We all have to go to zero, so it really doesn't matter. um, it it's you see, we have the biggest burden, because we have the biggest fault because we have emitted the most, right? The US, Europe, and
China.
then China. So we should go down fastest, you could argue, but we are also at the highest level because per capita, per person, we are at the highest levels, right? It's not that that Africa is per capita very high, or India. So, but the one thing that I think is most important here, it's not about justice really. It's about the fact that we'll all have to go to zero. So the economies that go down fastest will be the ones first ready for the future. I know this sounds like a trick, but it's not. You don't want to fight for the right to use typewriters in a world of computers, right? And that's a bit how it sounds. It sounds like I want my coal. I want to keep using my coal, and thereby I will be delayed in the infrastructure change that you will need in the next after 20 years.
You probably have heard already some feedback. I mean, probably like a broad feedback if it comes to outcomes of your research. Do you have like any feedback from policymakers, for instance? Do you know that the results reach up to them?
Yes, we really had a lot of media attention in the last week or two, and it's been once around the world, and now we get all these requests to give talks. Um, the the fact that the costs of climate change are bigger than the costs of climate mitigation had been around already from the Stanford analysis. Now our numbers are bigger, and I think they're a little, they're even more founded. We really appreciate the Stanford analysis because it was groundbreaking, yeah, and we're just doing it like a little extra stuff. But so this idea has been around. I think it'll be discussed again, um, and we're happy to help and discuss it. Yes, there's actually a lot of interest also from industry.
Yeah, but don't you think that also our governments in Europe, in the US, everywhere around the world should discuss the results of this research just now, like during their meetings? Because, because I have impression that they think only like 4 or 5 years term, elections term, and then they just don't don't care.
You're right, but for a long time we were talking about climate change as something that's really a long time in the future. Now we're talking about the next 20 years, which is 4 cycles of elections. So yeah, we're feeling the impact of climate change already now, not just because all the coral reefs are dying on the planet, not just because the Arctic sea ice is melting, or not just because we have tipped the Western Arctic ice sheet, but because we see the floods, we see the heat waves. The 2022 heat wave costs about 60,000 people lives in Europe. And the 2003 heat wave, the same. 2019 was really bad. Yes, we feel the impact.
Yeah, but do you feel do you have impression that politicians also feel it? I mean, that they.
Well, we have to. You see, we had these huge demonstrations in Germany and around the world by Fridays for Future, and now they have been dismissed because of what Greta says here and there. But it's Greta Thunberg is saying, but the main message of the young people remains the same, and is basically we have a right to a future, to have a proper future. And I think you see in Germany, at least my experience at the moment is that because the pressure from the people from the street is less now, politicians go back to the old way of getting away from the climate protection. Even though in Germany everyone said they want to stay below 1.5 degrees, now they're withdrawing from a lot of statements, and I think we shouldn't let them. We because it's our climate, it's our future.
Yes, exactly. Like even like couple of weeks ago, we had a huge demonstration of farmers in Poland, and of course they were against the European Green Deal, which is to protect the farmers and agriculture against the climate change. And only now, it's really like quite funny, or not even funny, but like 3 weeks ago we had like very high temperatures in here, like 20, even 27, so everything raised, all plants. And now we had like very low temperatures, and a lot of our plants were destroyed, and now they are just like oh my god, everything was destroyed. So I
Yes,
mean, they don't
you see,
believe, or it's like a kind
it's
of
really
contradiction.
short-sighted to say that we want to we the farmers also in Germany and around Europe have been demonstrating a lot against this, and it's really short-sighted because the farmers will be suffering a lot, and with the agriculture, obviously the population will, because they're feeding us, right? So it shouldn't be a one against the other. The farmers have a very strong interest to stop global warming.
Exactly, that's what I think. But I think that, like if they deny it and then they see the effects, it's a little bit contradicting to me.
It's not a good idea to deny physics. I can tell you that.
We have another question. What do you think how future generation will think about us being not economically efficient or just plain stupid, and how world will look in example 2050?
Well, we have, just as an example, we have seen sea level rise of 20 centimeters. That's not a lot over the last 100 years, 150 years. But we have caused a sea level rise of 2.5 meters already now. So for every degree of warming, we get 2.5 meters. It'll take centuries to unfold. So in 2000 years, people will remember us as the guys who started sea level rise, which is still ongoing. So, and sea level rise is not a threat to people because we'll just withdraw. It's very slow, but we'll just eventually have to hand over cities like Hamburg, New York,
Shanghai.
Shanghai, Calcutta, right? I actually don't know how Warsaw is, how high it is up. So I should have prepared that. I didn't look it up, but yeah.
So yeah, and
No,
yeah,
not
what
Warsaw. Danzig, obviously.
yeah, and how the world will look in 2050. It was the rest, the part of the question.
Well, the world in 2050 is already basically, it's almost determined by what we've done in the past. So it'll be about 2 degrees of warming, which means 4 degrees on land, which means a doubling of the rainfall event frequency. So the extreme rainfall event frequency. We will have passed the Greenland ice sheet. We will have passed the Antarctic ice sheet threshold. The Arctic sea ice will be gone in the summer, and coral reefs will be dead. That's it. There's more, but that's what it is. So, what you have to prepare for personally is an increase in the frequency of extreme extreme events. So that's not just extreme rainfall; it's also extreme heat and extreme cold events, even because it sounds like a contradiction, but the Arctic air we are protected from the Arctic air by the so-called jet stream, and this is starting to meander, is doing waves more and more frequently, and whenever that happens, sudden bursts of cold air come into Europe or the United States and also Russia, and cause extreme snowfall events or cold spells. So more ups and downs. That's what we have to face in the future.
And I mentioned this during this conversation, but I would like to refer once again to the simple fact that Europe is warming the fastest in the whole world. What does it mean for us, like practically?
Yeah, it basically means that everything is that we say about the world is worse in Europe. That's basically what it is.
Yeah, but like as it comes to results, like I don't know, more heat waves, more rain.
Exactly, that's what it is. Yeah, it's that's exactly what it is. And I want to mention, you said we are only 7% of the world emissions. Well, you see, like they always say, Germany has only 2% of the world emissions, but it's one out of 195 countries. So we are only 0.5% of the countries. So we have 2% of the emissions, but we are only 1.5% of the countries. You should do this per person, right? But per person, we are not good. We are way above average on the planet, right? Also in Poland, also in Germany, of course.
Yeah, like for instance, compared to Latin America or Africa. Yeah,
of course, yeah.
Because I think that it's also very important to highlight, to stress here that richer you are, more emissions you put to the atmosphere. Just like.
But also, it's really a race against who's the first in the future, in the new world, and the new world will be renewable. There's no doubt about it. So Let's
Not
just
nuclear, not nuclear, because
nuclear is
some
not
stuff-
is not an option for the world. If Austria wants to, Austria doesn't want to go nuclear. They really don't like it. If France wants to go nuclear, that's fine. But but you can't have nuclear as a global solution, because then you would have to switch from uranium, which is a limited resource, to plutonium, and which means that everyone who should get energy should get plutonium, and I think that's not a good thing. It's not a good idea.
Okay, and our time is up, so thank you very much for this conversation. I hope that we explained the research and its result as best as we could. I would like to remind you that Professor Anders Levermann from Potsdam Institute for Climate Impact Research was our guest. Thank you very much.
Thanks.
I drodzy Państwo, jeżeli chcecie mnie Państwo wspierać, zapraszam na Patronite'a. Tutaj jest link, jeżeli chcecie Państwo więcej takich rozmów, a także jeżeli chcieliby Państwo, żeby taka rozmowa ukazała się również z tłumaczeniem, to zapraszam do wsparcia. A już jutro na kanale klimatycznym porozmawiamy sobie o prawie energetycznym w Polsce i o tym, co musi się w nim zmienić, żeby nastąpiła szybciej transformacja energetyczna. Zapraszam na godzinę 20 tym razem.